Tuna fishing using purse seine nets is an efficient and large-scale technique in modern fisheries, widely applied around the world, particularly in tropical and subtropical seas where tuna schools migrate, from the Pacific and Atlantic Oceans to the Indian Ocean. Professional fishing fleets use purse seine nets to catch tuna species such as yellowfin, big eye, and skipjack, which make up the majority of the global tuna catch. The main feature of this method is its ability to harvest hundreds of tons of tuna in a single trip, which can last anywhere from a few days to several weeks, depending on the size of the vessel and the abundance of tuna near the coast. Before setting out, thorough and professional preparations are made. Tuna purse seine vessels are typically 50 to 100 meters long, equipped with modern machinery, spacious work areas, and devices such as forklifts, winches, fish receiving decks, and refrigeration systems, including refrigerated seawater, RSW. In addition, the vessel is staffed with an experienced crew, including the captain, marine engineers, refrigeration engineers, mechanics, and teams working directly with the nets, as well as tuna school monitoring specialists, such as observers or individuals skilled in detecting signs of tuna aggregation. Once the ship is fueled, supplied with food, fresh water, and necessary items like buoys, nets, ropes, sonar, radar, and fish finders, it departs from port and heads toward distant seas where tuna are known to appear. During the journey, equipment such as sonar, ultrasound, and radar are constantly used to detect the locations of tuna schools or small fish that tuna typically feed on, such as sardines and anchovies. The crew, especially from a lookout tower called the observation station, scans for clear signs like shimmering streaks on the water's surface, flocks of seabirds gathering or flying fish, which indicate the presence of large schools of fish beneath the water. Upon detecting a school of tuna, the captain signals the crew to prepare. A smaller vessel, called a skiff, is lowered into the water to pull the leading end of the net, forming a long circle that can be 1 to 2 kilometers in length and hundreds of meters deep. The crew uses cranes and pulley systems to encircle the tuna school. One end of the net is held by the mothership, while the other is controlled by the skiff. After the net is deployed and surrounds the tuna, the bottom line of the net, called the purse line, is pulled to form a massive watertight pocket, preventing the tuna from escaping. The process of deploying and closing the net requires speed and precision to ensure the tuna school is fully enclosed without scattering. Once the net is completely closed, the tuna are trapped in the pocket, and the process of hauling the net begins. Machinery slowly pulls the net back toward the ship, while the crew works continuously, coordinating smoothly. When enclosed, the tuna often become agitated, swimming in circles and occasionally leaping out of the water. Workers on the deck use nets or hooks to safely bring each fish on board. Some vessels use conveyor belts, water suction machines, or specialized pumps to transfer the tuna directly from the net into the refrigerated holds. Depending on the type of vessel, the tuna may be killed immediately by being immersed in ice or placed directly into refrigeration. Modern vessels are equipped with freezing systems that maintain a temperature of -40 degrees Celsius, or refrigerated seawater systems to preserve the tuna under optimal conditions, keeping the fish fresh. Market-grade tuna. Typically small yellowfin tuna ranging from 2 to 3 kilograms, or larger tuna species such as yellowfin and big eye, ranging from 10 to 30 kilograms, are kept. Smaller tuna, or those not meeting protection regulations, may be released. Some vessels use devices known as FADs, fish aggregating devices, which are floating objects equipped with GPS to attract tuna, as these fish tend to gather around floating debris. FADs are numbered and fitted with satellite communication equipment, allowing for precise remote location tracking and transmitting data on the size of the tuna schools beneath the water. While FADs enhance catch efficiency, they are also controversial due to their impact on ecosystems and other fish species. Vessels may stay at sea for anywhere from 15 to 60 days, depending on fishing conditions, weather, and effectiveness. A successful trip can yield hundreds of tons of tuna, enough to supply processing plants, canning factories, sashimi production, or export fresh and frozen products to major markets such as Japan, the US, and Europe. The tuna industry has now established a complete production chain, from fishing to processing. The purse seine tuna fishing method combines experience, patience, and skillful vessel operation. Additionally, trolling, also known as using artificial or live bait, is a popular method for catching tuna, especially yellowfin and bigeye. To fish effectively, proper equipment is needed, such as sturdy rods, powerful reel winches, high-strength nylon or braided lines, and baits like anchovies, mackerel, or live bait if available. The vessel typically moves at a speed of 4 to 7 knots. Depending on the bait and tuna species, the bait is attached to the end of the line and cast about 30 to 100 meters behind the boat. The fisherman must observe the tuna's response through the rod tip, since tuna bite quickly and aggressively. When a tuna strikes the bait, the fisherman must react swiftly, jerking the rod to hook the fish's jaw, and then adjust the drag to avoid breaking the line or injuring the fish. Hauling in the fish requires advanced technique. The fisherman must keep the line taut, avoiding slack or excessive tension. Sudden, strong pulls could cause the fish to break free or the line to snap. Additionally, the fisherman must take advantage of moments when the tuna tires to reel in quickly, while also being ready to handle strong resistance as the fish nears the surface. When the tuna is close to the boat, other crew members may assist by using hooks or nets to bring the fish on board safely, requiring good coordination to avoid accidents. In trolling, timing and location are crucial. Experienced fishermen rely on indicators like the color of the water, the presence of seabirds, or schools of bait fish to predict tuna locations. Knowledge of water temperature and weather conditions also plays a key role in increasing success rates. During trolling, the boat typically circles the area where fish are found, deploying multiple lines at different depths and distances to increase the chances of attracting tuna. Some fishermen use floats or reflective panels to simulate a school of bait fish, sparking the curiosity of the tuna. Tuna fishing by handline not only requires strength and equipment, but also a deep understanding of tuna hunting behaviors, swimming speeds, and reactions. This skill requires constant practice, along with the ability to observe and adapt quickly to different situations. Skilled fishermen can feel the pull of the fish, knowing when to let out the line to tire the tuna, and when to reel it in to shorten the catch time. A trolling session can last for hours, and catching a large tuna is the result of a perfect blend of human skill, technique, and nature. In addition to technique and experience, the physical strength of the fisherman is also crucial. Holding the rod and controlling the line for long periods, especially when facing tuna weighing from several dozen to hundreds of kilograms, requires endurance, stamina, and intense focus. Each battle with a fish is a major challenge, sometimes lasting for hours, requiring the fisherman to maintain a stable posture while using strength from the arms, back, and legs to avoid exhaustion. Many seasoned fishermen even customize or modify their rods, adding belly straps and shoulder lines to reduce pressure on their bodies when pulling in the fish. Before performing the trolling technique, thorough preparation is key. Prior to heading out to sea, the fisherman and captain typically discuss a clear strategy based on ocean data and seasonal experience to determine the best time and location. The boat is often equipped with GPS, sonar, fish finders, and marine compasses to assist in locating tuna schools swimming beneath the water. The number of baits, the length of the line, the type and number of hooks are also carefully considered, depending on the species of tuna and the specific conditions. In many cases, the fisherman needs to adjust how the bait is rigged or alter the trolling style, switching from near-surface trolling to mid-water trolling to align with the tuna's hunting behavior. When the fish is hauled aboard, proper preservation is critical to maintaining the quality of the meat. Fishermen typically immediately stun the fish by cutting the arteries and then immerse it in ice or place it in the refrigerated hold to keep it fresh. For larger tuna, specialized cooling boxes or onboard freezers may be necessary for long trips. High-quality tuna will be sorted for export to major markets like Japan, where each piece of fish must meet strict standards for freshness, color, and texture. In many coastal fishing villages in Japan, the Philippines, Indonesia, and Vietnam, the trolling technique is not just a profession, but a tradition passed down through generations. Experienced fishermen teach the younger generation the secrets of tuna fishing and vessel operation, helping them understand that successful fishing is not only about strength, but also requires patience, keen observation skills, and in-depth knowledge of the ocean. At sea, through long nights facing strong winds, rough waves, or storms, the fishermen patiently wait, because at the right moment, a tuna striking the bait can bring in a large harvest for the entire boat. It is these elements that make the trolling technique so captivating. The battle of wits between man and the ocean is always full of challenges, but the tireless work on the vast sea will yield a well-deserved reward.